Hey everyone, and welcome to this video. Today we're going to be talking about how to factor numbers, in other words, divisibility, right? So when it comes to factoring, it's sort of like taking times tables that you know and remember from basic math and doing it backwards. So for an example, let's talk about A. When we are trying to factor the number 5, you should ask yourself, what numbers can I divide evenly into the number 5? Well, any number for that matter, you can always do 1 in itself. So for 5, we know that we can put 1 and 5 together to make it all work out. But it doesn't just stop there. Let's try and see if 2 is a factor of 5. You will quickly come to learn that 2 is not a factor of 5, but we can show you why. So 2 divided into 5. 2 goes into 5 2 times. 2 times 2 is 4. Subtract 1, and so you now have a remainder of 1, which means 2 is not a factor of 5. And you can repeat this process for 3 and 4, and you'll see the same issue, that it's not evenly a factor. So, for problem A, the only factors for 5 are 1 and 5. In this case, we can also call this number a prime number because its only factors are 1 in itself. Let's move on to problem B. So for problem B, we have the number 10. Now 10 is going to be more challenging because it has more factors. Let's talk about how to find them. First and foremost, we always know that a factor is going to be 1 and itself. So we've got 1 and 10 to start. Now let's just go along the list. Let's see if 2 can factor into 10. Well, 2 goes into 10 5 times. 2 times 5 is 10, so we get a remainder of 0. That means that 2 and 5 is also a factor. Now you're probably picking up on the pattern here. You can see that if we took 3 into 10, it just wouldn't work, right? We'd be left with a remainder. Same thing goes for 4. We can check 4 just for the sake of practice. 4 into 10. 4 goes into 10 twice. That leaves us with an 8. Subtracting it, that's 2, and we have a remainder of 2, and that will not work. So that means our only factors are 1 and 10 and 2 and 5. Let's move on to problem C, which is 70. Let's talk about some tricks and techniques, things that we can do to help ourselves, because obviously with 70, there's going to be many numbers that we can try dividing into it, and that's going to be challenging. So to start off for problem C, we already know that 1 and 70 are going to be our answers. There's a couple other things here. Notice that 70 ends in a 0, or it has a base of 10. Any number that ends in a 0, you're automatically going to know that 10 is one of the factors. So you can ask yourself, what number times 10 will give us 70? Well, 10 goes into 70 7 times. That gives us 70 with a remainder of 0. So that factor is 7 and 10. Now we can look at some other things as well. Since we have a number like 10 in our factors list, we can also assume that all the factors of 10 go into 70. From problem B, we remember that the factors of 10 are 1 and 10 and 2 and 5. So we already have 1 and 10, so that means we are missing 2 and 5. So we can put 2, we can put 5. Now we just have to work out what numbers are the other half of that factor. So to do that, we take 2 divided into 70. 2 goes into the first digit, 7, 3 times. 3 times 2 is 6. Subtract that out 1. Bring down the 10 and 5. So there you go. We'll box that in blue. You get a 35 and 35. Let's do the same thing for 5. So 5 goes into 70. Okay, 5 goes into the first digit 7 once. 1 times 5 is 5. Minus it out, that's 2. Bring down your 0, 20. 5 goes into 20 4 times, 4. And that leaves us with 20 and no remainder. We can box that in red. So 5 and 14. And again, we can look at this list. We have 35 in blue and 14 in a reddish orange. 35's factors are 7 and 5, which we already have here and here. And then 14's factors are 2 and 7, which we already have. The last thing we need to do is make sure that there aren't any other numbers that we can pull out of 70. Some common ones to look for are 3, 5, 11, and 13. Those are prime numbers that like to sneak into these types of problems that may surprise you when they're factors. I'll tell you with 70 that's not the case. And these are all of the factors for the number 70. So let's put a nice box around our final answer, which is 170, 7 and 10, 2 and 35, and 5 and 14. All right, on to the last number. Let's work on option D, which is 73. So just like all of the other problems, the first factors we always have is the number 1 and the number itself, which is 73. Now let's talk again about some tricks. Like with 70, the 0 gave us a hint that the number might be divisible by 10. In D, with 73, the trailing 3 gives us a hint that we could try dividing by 3. So let's give that a shot. 3 going into 73. 3 goes into 7 twice, giving us a 6. Subtracting that gives us a 1. Bring down the 3 for 13. 3 goes into 13 4 times. That's a 12 with the remainder of 1. So 3 and 24 are not factors of 73. Okay, so now we start wondering, are there any factors? Let's try some of the other tricky ones. Let's try 7. You can probably guess that 7 is not going to work because 7 times 10 is 70, and 7 times 11 is 77, so that will never equal 73. We could try 9, but that's not going to work. 11, we know 11 doesn't go into 73. So how about 13? That's an uncommon number that maybe would give us a hint. So 13 into 73. Well, if we take 13 times 5, that'll give us a 5, carry the 1, 65. And 13 times 6, that's going to give us an 8, carry the 1, so that's a 7, 78. And so neither of those are 73. So we know that 13 isn't a factor. So now we got to think, maybe there aren't any factors, and 1 and 73 are the only factors. And that is true. Those are the only factors. Therefore, we say that D, the number 73, is a prime number. So we've talked about how to factor several different kinds of numbers, along with some really good tricks on how to do that. Up next, we're going to talk about finding the greatest common factor, which is going to be a very powerful tool as we move forward. Thank you so much for watching this video, and if you have any questions, feel free to leave it in the comment section.